What makes P3 so hard? Some people even think that P3 is actually harder than P4, and they actually do get lower scores than P4. Well, why is it? I think it's because when you have to integrate some function that would have been easy if you have done P4, but it's actually very difficult otherwise. So today we're going to look at integration in P3. Now, what I would do today is just bring the actual past questions from the past papers, and we're going to go through 6 of them today. These 6 questions will rely on the same techniques. There are 2 main techniques here we're going to cover today, and these techniques are very crucial to nailing P3 integration. I'll try and make sure that the steps I teach today is going to be very simple and easy to understand. So make sure you stick around until the end because the last question is actually quite challenging. So before we go any further, I need to give you some intro for the 2 techniques that will be covered today, and both of which are actually called reverse chain rule. So what are they? The first one is when you have to integrate something like a fraction of expression where the numerator is the derivative of the denominator. And when you have to integrate something like that, you're going to have to try ln of the denominator function in the absolute sign like that. And what makes it a little tricky is you need to do some correction factor. I call it correction factor k, and we'll cover that today too. And of course, you have to plus c. So that is the first form. So it's where you try differentiate the denominator and you get the numerator. All right, so that's the first form. The second form is kind of similar. It's where you try to differentiate the function on a side where it might be to the power of n, and then you get the function next to it, right? So this is where you have a product of 2 functions where one is the derivative of the inner function next to it. So here we have, if you try let's say this is say sine x to the power of 2, and if you try differentiate this, you will have a cos x around here. Although sine x is to the power of 2, but you have cos x outside, that will be this form. Okay, so it's going to be, when you integrate that, you're going to get f of x to the power of n plus 1 divided by n plus 1, and the correction factor again, k. All right, we'll cover these 2 forms today, and I'll make sure that it is simplified for you to understand. Okay, now these 2 techniques, when they appear in the papers, if you don't get used to using these, they're going to be quite tricky to see, right? So we'll use these 2 rules today. Okay, let's go to the first question. So there you go. This is P3 June 2022. And it says find the integration of that, right? So, okay. But because this is just part of the actual question, that's why you see k lurking around there. Actually, there is a follow-up question there. But we're just going to keep k there, right? Because I didn't want to change anything of this actual question. So we want to integrate that. Now you see, if you try differentiate the denominator, right? So let's try differentiate the denominator first. You get, okay, I'm just going to write like that. So when you try differentiate the denominator, you get 6x, right? Those of you who are doing P3 now should know that this is 6x quickly. Yeah, without me showing too much to you how to do. Now, but 6x is not exactly 9x. So here I try differentiate the denominator. As you might remember, we're going to use the first form, the first technique. When you differentiate denominator, you get the kind of like the numerator, but it's not exactly the numerator here, right? Because 6x is not exactly 9x. Right, and this is where the technique here becomes useful when you know how to do this. So you think for yourself how you make 6x become 9x. Yeah? So simply, I'm just going to use maybe a different color here. Okay. Simply, you can do that by multiplying across on both sides What do you want? You want 9, right? So you multiply by 9 and divide by what you don't want, 6. Well, that becomes 9x already, yeah? But we have to do both sides, so I'm just going to do 9 over 6 here. Okay? And you can wrap it up a bit. You can tidy up a bit because that would be 9x on the right-hand side, but the left-hand side you would have 3, wait, hang on. You would then have 3 over 2, yeah? And d by dx of 3x squared plus k equals 9x. Well, what's the point of this? The point of this is to extract the correction factor here. That is the correction factor. We're going to use that in our integration form. Because if you remember, that would just be ln of the inner function. Because we don't know what k is yet, we're just going to keep k around. Okay? And that 3 over 2 right there in front will be put here. That's it. Honestly. And okay, we might have a c here because this is indefinite integration. That's it. Make sure you maybe go back and try understand again if you didn't. Okay? That is the reverse chain rule, the first form. Let's try it again. Next question. This is P3 January 2022. Well, a little more difficult, a little more intriguing here because you are dealing with trigonometric functions. Okay, so show by algebraic integration that blah, blah, blah equals ln A. So we have a definite integration this time. We need to find the constant A as well, where A is to be found. All right, so let's try that, yeah? Again, so because we've been using the reverse chain rule techniques, right? So surely this is one of them. But before you jump to any conclusion, you should try differentiate. So do you think it's like differentiating the denominator and get the numerator, or differentiating the side and get the other one? Well, it's the first one, right? So differentiating, you try right like that. 1 plus, so it has to be the whole thing, the whole denominator. Differentiate it. And then what do you get? Differentiate 1 goes to 0. Differentiate 2 cos x, you get minus 2. Just going to leave some space here. Minus 2 sine x, right? Yeah? Let me bring it down a bit. I tend to write like, flying off the level there. Okay. So it's minus 2 sine x. But it is not exactly the numerator. Because the numerator is 4 sine x. So how do we make it so? Well, we multiply by minus 2, right? So this might require a little mental math a little bit if you want to make it faster, or you can use a calculator, of course. I mean, for those of you who are more used to using a calculator, feel free, right? But we are gonna multiply by minus 2. So I put minus 2 here and times minus 2. Now, you don't need to write anything after this now because this is all you want. You got what you want now. You want to know if differentiate the bottom, you get the top. And it does kind of give you the top here. It just needs some manipulation. That correction factor minus 2 there, you got it already. So you know now that the integration of that, I'm just going to write that, yeah. Just the same thing, just so you know. It's going to be, again, because you differentiate the bottom, you get the top. It's going to be ln of the bottom. Okay? But with the correction factor, minus 2. Nothing hard here, right? Okay? Now, because in this question, we need to complete, right? So I'm just going to tidy up the space here a little bit because I need to substitute the bounds. Okay, that's just to show you there. Okay, so we need to substitute the bounds of 0 and pi over 3. Okay, so it's just going to be, I'm just going to take minus 2 all outside there. And then ln of 1 plus, so if I put pi over 3 in, it's 2 cos pi over 3, 1 over 2. So 2 times 1 over 2 there. And then minus ln 1 plus, and then we have 2 times cos 0. Cos 0 is 1. So 2 1 plus 2 there. Okay? So it's ln 2 minus ln 3, right? Ln 2 minus ln 3 in there, it's ln 2 over 3. So this is minus 2 ln 2 over 3. Yeah? And because we need to make it ln a, this is not ln a yet. I need to, push the minus 2 to be the power. So it's going to be ln of 2 over 3 to the power of minus 2. Well, the power of minus 2 is just flip the fraction, 3 over 2 to the power of 2 instead. So I'm saying that 2 over 3 to the power of minus 2 is actually the same as 3 over 2 to the power of 2. So that would be 9 over 4. I'm just going to rub this off because it seems like I don't have space now. So that would just be the answer then for this one. Okay? But the key thing you need to learn here is how you integrate that in the first place. All right? It's the reverse chain rule technique. Well, let's try another one like this. Okay, this might look a little more intriguing. Now we have to integrate that. Now, people might think, okay, is this partial fractions? Well, you can try. But it is easier if you try differentiate the bottom first. I mean, partial fractions might work or might not. But if reverse chain rule works, you should use it because it's quicker. Then you don't need to, because you don't need to do the partial fractions and then integrate later on, right? Usually if one works, the other might not. It's like when you integrate, usually a few techniques just work, but other techniques might not work, right? Okay. So we try differentiate the bottom, right? The whole thing, don't forget. Yeah. Now I differentiate, so I get 6x quickly minus 4. Well, as you can see, it is not exactly the top, but if you see more carefully, it is kind of the top, a multiple of the top, because this is just 2 factorized out times 3x minus 2, isn't it? Right? That means to make it exactly like the top, I need to multiply by a half. Don't I? So I'm just going to multiply by a half like that. So I'm just going to do 1 over 2 multiply that whole thing again. And this is multiplied by 1 over 2. Just to show some working here, yeah? And that will be our correction factor k. Because again, this will be equal to ln of the whole thing at the bottom multiplied by 1 over 2 outside like that. I mean, that's done. Really. That's just done. Plus c, of course. I hope that was easy for you. And that is kind of like the first technique covered. All right. I just prepared 3 questions for this. Let's have a look at another technique. Okay. So this is P3 October 2021 question 5 II. Well, you can check the question. I brought it from the actual past exam question. Okay, so we need to integrate that. Now, there is no denominator and numerator anymore. It's just 2 functions, a product of 2 functions, one with some power, one with some exponent, and the other is just kind of like simple x there. So we have x and then x squared plus 3 to the power of 7. Okay, so if you still remember, if you try differentiate the inner function of a power, of the exponent function, and then you get another function on the side. That is the second form there. This form is a little trickier than the first one because you need to do the power there. This is more like a reverse power rule. It's the power rule for integration. As you can see, you add power by 1, you divide by the added power. But how do we use it here? Let me go back. So, you try integrate the inner function, and when I say inner function, it's just the thing inside without the power. Don't take the power yet. If you want to make this simple, maybe I'm going to show you how here. So you differentiate the inner function, everything inside, without the power. Okay? Yeah, that's the inner function. And then what do you get? You get a 2x, right? Simple. Now again, 2x is not exactly x. You need to multiply it by a half, right? So that would be our correction factor again. So I'm just going to do a half here multiplied, a half here multiplied to make the equation work here. So on the right side, we already get x. What next? You can now do the power rule, like the reverse chain rule of the power rule. So this whole thing will just be equal to the power. If I bring that form again, I'm just going to write here. So it's the correction factor, and then we have fx to the power of n plus 1 over n plus 1 plus c. So according to that form there, we are going to get k, which is what we found to be 1/2, multiplied by the inner function, x squared plus 3, to the power of n, which was 7 before we integrate, now has to be 8 because n plus 1 and divided by 8. And of course, now the 2 times 8 will become 16, right? So that's going to be, I'm just going to write down here maybe. So 1 over 16, x squared plus 3 to the 8 plus c. That will be the answer there. Of course, just to check, just to do a sanity check here, you can try differentiate that answer expecting to get this, this whole thing here. And we can try to do that quickly here. So I'm just going to differentiate my answer here. Yeah. And see what I get here. Okay. So I'm just going to differentiate now. So we use chain rule here. And if you haven't seen the video that I walk through the very simple technique for chain rule, just check that video right there. Yeah. Now, differentiate the outermost function first. It's something to the power of 8. So you bring 8 down. And then that thing to the power of 1 less, which is 7. And then you differentiate the inner function, which is 2x. Yeah, you differentiate x squared plus 3, you get 2x. This is chain rule. All right. So if you simplify, 8 over 16 here will cancel to 1/2, and then 2 cut here. You get exactly that, right? You can try check that. You get exactly the integrand of the question. Yeah, exactly the same thing. Just for sanity check, yeah, that we got the right answer here. And you can always do that for every time you have to integrate something. You can try differentiate your answer, see if you get the integrand. This is called integrand, yeah? All right, so that's the first example. Let's go to the next one. Of course, this probably is a reverse chain rule again because this is the video about it. But this might kind of trick you a bit because it doesn't look like you have two functions on the sides. This is more like a fraction. But don't let that fool you. Because whenever you see anything like this, you can try check yourself if you have one of the rules or not. So this is also can be written as that. I mean, of course, you can try differentiate the whole denominator. See if you get the numerator or not. So you try and come back later and you will see that if you try differentiate the bottom, you will not get the top because you have the power 3 there. Yeah, the annoying part is the power 3 there. It's not the first form then. But if you change it to like this, to the power of -3 instead, you will see that the second form might work. But we need to try differentiate the inner function first. So we try differentiate the inner function, the one with the power. The one with the power, but when you differentiate, you take the power out. That's why I didn't bring the -3. Differentiating it, we get 2e to the 2x, right? It's not exactly the e to the 2x again, but now you have to know that we can correct, right? We multiply by 1/2 again to cancel that 2 to make it exactly like the function on the side. Okay? And this will be our correction factor. So this whole thing will become easy. We have that whole thing. So we have that whole thing to the power of minus 3 plus 1. So that would become minus 2, right? And then we divide by minus 2 as well. And then with the correction factor multiplied here and plus c. If you tidy up everything, it's going to be just minus 1 over 4. And then all that to the power of minus 2. So that's it. Yeah, that's the answer there. And of course, you can try differentiate it back, see if you get the integrand there, but surely you should. And that was it for this one. All right. Make sure you understand every question in this video, right? All right, number 6. Now this one, I modified the question a bit. If you check the actual question, you will have seen that there was the first part where you need to prove sine 3x equals something something. But I cut it out because I have seen this exact kind of integral in a P4. It's actually part of the P4. So you would have to do by parts integration, and then you will get that thing in the second part. If you know how to do this using a reverse chain rule, it will be very helpful for that. So let's do it without having to prove anything first. Because if you prove the triple angle first, I mean, if you check that question in the past paper, it's asking you to prove the triple angle for the sine. I mean, this question is not way out of the scope. It can even come up as the P3 question. So we're going to do it, right? We're going to try do it, yeah? If you don't mind. And it's going to be challenging. I mean, you can also apply this same technique to cos cubed as well. So this is sine cubed x, yeah? Or is sine x all to the power of 3. So what do we need to do first? Well, I mean, we can't really integrate sine to the 3 directly. For those of you who think that we're going to use the power rule, that's wrong. I've seen this mistake many times over. It's like some people think that you're going to get sine to the 4 over 4. No. Don't go that way, right? The power rule like that can only be used when the inner function, the thing that is powered, is a linear function. So if instead of sine, you have, say, ax plus b to the power of 3, then yeah, you can use reverse power rule. So I would like to split, yeah? I'm going to split into sine and 1 minus cos squared x. Hang on. So because one sine is taken out and the other part is sine squared. And then I use the trig identity to make it 1 minus cos squared instead, yeah? So far so good, right? And then if you multiply out, you get sine x minus sine x cos squared x dx, okay? So just put brackets there. Some of you might see already here that we should split the integral. So we should split so that we integrate separately because the first integral is kind of easy, or the second one might be a little troublesome. So there's 2 integrals we need to work on. The first one is easy. Integrate sine, you get a minus cos, right? That's easy. So I'm just going to put a minus cos here already. What do we do with the second integral? Well, I mean, we have been doing reverse chain rule for this whole video, right? So if you try, see that the cos is kind of like with the power, and the inner function of that exponent is just a cos x. If you try differentiate a cos, you get a minus sign. So that's kind of like on the side, right? And for that purpose, let me just actually push the minus inside the integral here so that, you know, when you differentiate the cos, you get exactly minus sine x. And we don't need any correction factor there because it's exactly what we got there if we differentiate the cos. So because I'm just going to write here, differentiate a cos x, you get a minus sign. And this is exactly the side function here. So there is no need for a correction factor, right? What is that again? It's the second reverse chain rule technique. So we plus the power add by 1, so it becomes cos cubed divided by the added power 3. And because there is no correction factor here, that is pretty much done. Okay? And then now we add back the bounds, right? Okay, so we have to put the bounds in like that. So that's 5 over 24 is the answer then. Just gonna write here. I mean, I might have done arithmetic wrong there, but there you go. The key part here is the how to integrate this whole sine cube thing. Alright guys, hope that was all useful. And don't forget guys, keep studying. Bye.